Students, today I'm going to explain you about 5 marks important questions for board examination. So the chapter name is Matrices and Determinants. The question here we have, for two matrices A and B, find the product and hence solve the system of equation. Okay, after finding product AB, we have to solve this system of equation. Now let's see the solution. Let us find first its product AB. Since 3 by 3 here also 3 by 3. So these two elements are same. The product is exist, and we have to multiply this with the help of row versus column. After multiplying with first row, first column, I'm going to get this entry. The same way I have to multiply. Okay, after multiplying this thing, what I have got here, you can see here, first row, first column, 3 into 1, 3, minus 6 into 0, 0, and minus 1 into 2. So after simplifying this thing, I will be getting 1. The same way this entry, second entry, I will be getting 0, and this entry also I will be getting 0. You can see this is an identity matrix. Okay, after multiplying AB, I'm going to get identity matrix of order 3 by 3. Now you can see which condition we can remember by looking at this expression AB. I'm getting it as I, which means we have already one property. A into A inverse, always what it is here, an identity matrix. So which means B is the inverse of A. So if B is the inverse of A, what you can write, A inverse is equals to what I can write here, B. So this is an important statement. Name it as equation number 1. Now consider the given system of equation. What we have, these are the given system of equations. Now write these equations in the form of Ax is equals to D, where A is coefficient matrix whose entries we have taken from coefficient of x, y, z. See, x coefficient is 3 and y coefficient is minus 6. The matrix I'm going to get here, coefficient matrix, A is equals to 3 minus 6 minus 1 and 2 minus 5 minus 1 minus 2 4 1. This is how I'm going to get A matrix. You can see A matrix here we have. This is the A matrix, and then capital X is nothing but variable matrix. The variables here we have x, y, z, and D is a constant matrix which is 3 minus 2 5. So constant matrix, these are the values. You can take 3 and plus 2, I have to shift this side, it will become minus 2, and this is 5. So this is the matrix representation of given system of equation. Now since we have Ax is equals to D, from here if I shift this A, this side it will become A inverse. X is equals to A inverse into D. Since we know A inverse is nothing but what? B into D. So you have to multiply B with D, so that I am going to get, see here we have 3 by 3 and this order is 3 by 1. Again the entries are same, so the product is exist. The product is here exist. And what is the resultant order I'm going to get here? 3 by 1 I'm going to get. See how I have to multiply again here. First row, first column. So what I'm going to get here? 1 into 3 minus 2 into minus 2, which is plus 4. Here we have minus 1 into 5 minus 5. After simplifying, I'm going to get 2 minus 3, 21, which is nothing but x is equals to 2, y is equals to minus 3, z is equals to 21. I hope everyone understood this solution. You can see the same way you can solve this problem also. You can try to solve this problem. If you have any doubt, just let me know. Kindly subscribe to the channel. Thank you for watching video. In this video we will be learning about determinants, and determinants, one of important formula is that, okay, adjoint of A whose determinant is nothing but det of n minus 1. Okay, adjoint of A is nothing but what it is here. It is just a cofactor matrix of A. Okay, cofactor matrix of A whose transpose you have to take. Whose transpose if you take, you are going to obtain a adjoint matrix. Okay, so whose determinant is nothing but what it is here, det A of n minus 1, where n is nothing but what it is here, order of matrix A, which is nothing but what it is, 4 we are going to get. If I replace 4 here, what it will become, det A whole to the power 4 minus 1 is nothing but det A whole to the power 3. So 27 can be written as 3 cube. So therefore det A can be written as 3. Okay, now what is A of adjoint of A? That equals to what it is here, det of I. Now A of adjoint of A is nothing but, det of A is nothing but what you have here, det of A is 3 into I. Okay, so this is the important formula. How we got this formula means, since we know A inverse is nothing but what, adjoint of A divided by det A. So now if I take this A this side, what it will become, or if I multiply A on both sides, A into A inverse, that is equals to adjoint of A into A, I can multiply either of this side. Okay, so divided by det A. So now A into A inverse, what it will become, I into det A, that is equals to A into adjoint of A. So I value, how much I value is nothing but identity matrix, det A value is 3. This is the value, so correct option is 3i. I hope everyone understood. Kindly subscribe the channel. Thank you.